Good evening, ladies and gentlemen. Welcome to our class today. We're dealing with Module 5, exploiting wired and wireless networks. So, from the perspective of a penetration tester, it will be wise to identify what the threat actor would attempt doing. I mentioned that part of the foundation that I was laying and which I would every now and then continue visiting with respect to the architecture of any service that a device would want to use is that the internet or the network, as it were, is structured in such a way that there must be somebody providing service, some other person attempting to get that service or requesting to use that service. Because of that, there's a coming together of more than one device, which is what makes a network. So a network is simply more than one device connecting or coming together. There are protocols that actually guide that, how the connection should happen. One of it, very basic one of it is IP, which means that every device must have a unique identity with which it can be known in the network so that when it is making a request, we know who is making that request. Now, with that, it gives a picture of the fact that um, exploitation or attacks, as it were, in any network, in to any device or any service, cannot happen outside a network. There must be some form of connection between the person requesting and the person giving, which is what usually the threat actor tries to hijack. So the conversation that occurs between the receiver or the requester, or this, let's put it this way, the client and the server, is usually um, on the basis of certain rules or certain protocols, and that is what this attacker exploits. And our network as it is today is structured in two ways. It is either wired, meaning that wires, you can see physical wires connecting the devices, which was the traditional one back in the day, which a lot of people were more, conversant with. And then the trending one today, which is wireless, suggesting that there are no wires connecting them. And the threats are actually way stronger on the wireless network than they would be on the wired. Not to say that they are totally not there in the wired network. They are. However, the wired is normally in a room. So to get to the wired network, you'd have to be physically present in the room. But in the case of the wireless network, you don't have to physically be there. All you need to do is just walk around. And because of how it is structured, you may be able to see the service set identifier or the SSID displaying the name where you now attempt to connect to it. And of course, you can gain access to the network if you have the proper credentials. So typically, what the attackers do or the threat actors do is they exploit more of the wireless network than you have in the wired. However, it doesn't mean that the wired is without attack. Now, typically, if you see a wireless network, it cannot exist on its own without a wired infrastructure. So normally the wireless network is like an extension, right, of the wired network for the benefit of those who don't have proximity, who perhaps don't have physical connection to the wired network. So it makes it very important to note that as a threat, as a penetration tester, what you want to do is to identify what possible ways could these bad guys, as it were, will attempt to exploit the networks, which is wired and wireless networks. So that's what today's module is about. It doesn't have any components, or as it were. We're going to be discussing them with respect to the kind of exploits that occur in wired and wireless network. And there are two, excuse me, there are two topic titles we're going to be dealing with, and that's exploiting network-based vulnerabilities and then exploiting wireless vulnerabilities. So that's what we're going to be looking at, how that these things are taken advantage of. One may perhaps be wondering, I think I mentioned this before. I said that it would be wise to ensure that as a cybersecurity person or a penetration tester, a good knowledge of the network, which happens to be the platform on which these attacks occur, are very, very, or is very, very needed. Okay, so let me just say are needed because the knowledge is just not one. You'd have to understand the structuring of the network, as it were, and then also understand the protocols that govern how these conversations occur. I said before now, which I'll keep reiterating every now and then, that um, the infrastructure. Somebody's asking a question. My volume, are you sure it's not your device? Please, can any other person hear me loud?
Yes, I can hear you
I hear you
clearly.
very well,
Okay,
loud
so,
and clear.
Mohammed, I think it's your
We
side.
Yeah,
can
we
Go
can
hear
ahead.
hear
you.
you.
We
Thank you
can
very
hear you so loud.
Thank you. Thank you very much, Afiniki.
Yeah, we can hear you.
All right, thank you. So thank you, Koi. So I think it is Mohammed. I think it's yours. So perhaps just try to increase the volume of your device. So, like I was saying, the knowledge of the network is very, very important. You cannot deal any form of cybersecurity knowledge, right, or penetration testing knowledge without knowledge of network. By the way, what are you trying to um, test as a penetration tester? What are you trying to, what as an ethical hacker? What exactly are you trying to hack? You are assuming the posture of somebody who wants to attack an existing infrastructure, a network. Now, network comprise of devices. These devices use services. These services are perhaps structured in applications or perhaps even hosted on devices or like computers. Now, the conversation that has to occur between the requesting device and the device who's given is what is the attention, is the object of interest, or let's say scenario of interest for the attacker. So as a pen tester, what you want to do is to look at the structure carefully and then identify what most likely will be attacked. And today we're looking at the network aspects. Very, very important. So cyber attacks and exploits happen every now and then. They keep evolving. You'd realize that this list is very tall and one is not even exhaustive, right? We cannot exhaust all of it. As we're speaking, you may even have that table populated with perhaps something very recent, and it keeps happening every now and then. And usually, the ratio of the people that it affects actually brings a particular attack to bear. It may happen to just very few people, and by the time it is weighed, they might decide to say, hey, you know what, this is actually not very, worthy of attention as we speak. So let's just go ahead and focus on the other. So there are quite a number of them. You might have heard of blue jacking, right? First time I heard about it was when I watched the movie back in the day. It was a series movie. It was almost um, ethereal, like almost not real. But it was a movie called Person of Interest, where in that movie they built a system whose job is beginning to become a thing today, whose job is to identify persons and based on their communications and interactions is able to suggest that this person is about to commit a crime. So um, they categorize people into two. You're either a perp, which is the perpetrator, or you are I think it's a victim. You're a perp or a victim, right? So the victim is the one who the crime is going to be committed against, and then the perp is somebody who's going to commit the crime. There was a movie also back in the day. Permit me, I use movies a lot because I notice every now and then they throw this knowledge in these movies here and there. So, and I'm a keen learner and I'm an avid reader. So I extract my examples and experiences from different places. There was a movie that was done by some guy. What's his name now? Tom Cruise. Those days, I heard the movie was almost a failure. At the point of shooting the movie, the guy, they were almost going to stop because they didn't have the resources, but then he pumped his money into it. And of course, the movie was written as a failure. But after the movie was released and it started airing, the movie shot in the blockbusters. He made lots of money, and the guy became mighty rich from it. The movie is called Minority Report. In that movie, they had a particular neural system, which was a human being, whose job is to predict the future, right? The person will just call someone's name, they identify a ball will roll and come out in a particular place, and to suggest that, hey, an attack is going to happen on so and so and so day. Why did I bring this particular example up? It goes to show that what movies project or perhaps even suggest, right, are more or less perhaps systems or technology or services or processes that are being worked on, and they just use the movie to, test how it's going to be. So every now and then I watch movies. I may refer you to one or two every now and then as we have this conversation. Okay, so cybersecurity, what I'm just saying is against the backdrop of the fact that cyber attacks or exploits, right? Or let's say cyber attacks and exploits happen like every now and then, right? More, so the focus will be to narrow down to the tactics or the techniques that these attackers use, which is what we're looking at in this case. So today we are at, or we are in, wired and wireless networks. So let's dive into the slides and see what we have today. Right. So the module title is Exploiting Wired and Wireless Networks. Module objective is explaining how to exploit wired and wireless network vulnerabilities, right? Remember I said what we're going to be doing here is explaining. The demonstration, like I promised, we're going to set a day up, maybe when we're done. Module 10 actually is where we culminate most of the activities, where we're going to demonstrate. At this point, we're explaining. So bear with the explanation. I'll just point you to one or two resources. I noticed some people are already even getting ahead and installing one or two things, which is cool. So let's see how it goes. So we're going to be looking at exploiting networking-based vulnerabilities and exploiting wireless vulnerabilities. So most times you'll observe that networking captures wired network. So let's start. Now, as an overview, we'll be conducting asset enumeration of the internal network as a precursor to vulnerability scanning. Remember, we said that assets are simply any resource or any target or any object that is of value to the person, the organization, or the community. Right. So enumerating it, of course, is like listing them, identify what they are, and then say, okay, these are most likely the things that would be attacked or be targeted. Right. Now, we want to focus on the systems that will potentially give us the most access to proprietary data, but need to run vulnerability scan on all in-scope target. Remember the scope we talked about before will be the point where you have permission to work on. You have the permission to target, to be able to identify the weaknesses that exist therein. And once assets are identified and we know what rules or protocols and services are running, now this is where the attacks occur. The attacks don't just happen on your system. Nobody just attacks your system because you have a HP, you have a Mac, you have a Vostro, right? Whatever. Nobody really attacks it. They attack it because of what it contains or what you are interacting with, what you have. And the rules here govern the services. And the rules in this case are the protocols, right? So we're going to be looking at identifying the protocols and services that are running on the network. Then we can devise exploits as a basis to do risk analysis. Remember that you're a pen tester. So the exploit is to look at those services, then attack them with one or two tools or one or two techniques. We also need to challenge the identity and access management system. Remember, we talked about this at the beginning. Identity and access management is the main thing. Without this, we cannot really identify the people who are in the network. This is where users are giving identity. And each identity has levels of privileges. This is where the management of their access is handled. So you'd have three categories of people every now and then. There will be perhaps the people who live there. If it's a school environment, it will perhaps be the faculty, which would be every staff, right? And then there will be the students, right? Then there will be the guest. Now, if you take it and bring it to any other organization, it's somewhat something like that. You may have the staff of that place, then you have the clients that they deal with, then you perhaps have guests. So they are normally categorized under these three. Now, it's good to also be certain about who each person is or who they all are. So identity and access management is that database that contains every user and their credentials. So we want to challenge that system to see if they are adequate to block even simple unauthorized access by internal users as well as more complex external threats. So I'm going to also attempt to look at conducting enumeration, right, and attempt various on path or what called man in the middle attack to gain further unauthorized access to account and data. So let's dive in. So now, network-based vulnerabilities and exploits can be catastrophic because the types of damage and impact they can cause in an organization can be huge, right? Now, imagine an attack on a bank, right? Imagine an attack on an education sector, let's say JAMB, an attack on SSC, WAEC, an attack on NAPTEB, any of those, organizations that host services for people. So there are certain examples that network-based attacks and exploits okay. There are many services that are attacked in every network, wired network. There's a Windows name resolution Network-based attack and exploits. Right? There's DNS cache poisoning attack. You know what DNS is? Like DNS is simply the service that resolves IP addresses to names, because we know that the devices on the internet do not use names. We have the names for the purposes of being able to read and know what you're doing. Those devices actually interact using identifiers or identities based on their protocols, which is IP. So there's a system that seeks to resolve every IP, a numeric number, numeric identity with an alpha identity, right? Then there's also attack and exploits against server block messages, right? There's simple network management protocol vulnerabilities and exploits for the people who do network management, or perhaps people who do network administration, right? Or server administration. This is a very big thing because these are tools that we use to perhaps manage the network with respect to getting information, right? That are traps. When we say traps, we mean that these informations are actually collected and they have different levels of severity from zero to seven, seven being the least, zero being the highest, right? So there's this system that actually, gets like a feedback of what happens. It keeps a record of everything that every device does, every user does. So we have this particular protocol or service, which is in the network. We have a service in the network, which is guarded by this protocol. And that protocol helps to keep record of everything that occurs, right? Then we'll see simple mail transfer protocol, which is for mail, the vulnerabilities that happen there. So this is enumerating them now, right? They also have file transfer protocol for the purposes of downloading files or uploading files. And the pass the hash attack, on path attack, which is what we used to know as man in the middle attack, right? Then there's SSL stripping attack. There's denial of service and distributed denial of service attack. Age old, it's been around. If you ask me, I'll tell you that most of the attacks actually stem from here. They just grew from here and had different names. And the reason is because the denial of service attack is premised upon the conversation that occurs between the client and the server. So typically, I have explained this earlier, previous classes. The client will make a request, and there's always a traffic which indicates the beginning of the conversation, which is generated and sent by the client. That is normally captured as a synchronization request. The request hits the server. The server would, of course, acknowledge I've seen your synchronization and I am also sending my synchronization. At that point, they have to agree on the size of traffic and what they can take per time. That will determine the number of a window, right, that is going to be sent. Each window has sequence numbers. And so why that is possible is why that is so is because in the event that I didn't get everything completely, what will happen would be that I make a request, say, hey, we agreed we're supposed to have 10 windows, but I'm missing 3 windows. And the windows I'm missing are numbers 7, numbers 8, and numbers 9. So instead of sending the entire page again, send me those numbers. Now, that happens between the client and the server. So what the denial of service attack harps on is that it knows that a server would always respond. Now, because it's going to respond, it responds to any traffic sent at its titled the synchronization. What I'll do is I'll overwhelm that server with that request. I like giving this example. It might not be, I don't know how you all grew up. I grew up on the streets, very rough, like hands-on. And we had this very stupid thing. Now looking back at it, then we thought it was a smart thing we're doing, but looking back at it, it was bad. We're actually, as children, stealing from someone and trying to make, ourselves look nice or perhaps feel good. This is how it used to work. You go into a shop, there are like 5 or 4 of you as kids. You carry 50 kobo. Then it was 50 kobo. I think it was 50 kobo note, right? You go into the shop with 50 kobo note, and then the man sees the money, of course, his attention is aroused. So somebody asks, sir, please give me biscuit, right? While the man is trying to get biscuit, the other person now says, how much is sweet, right? The other person now asks, how much is bubble gum, right? And all of these are kept at different places. The focus here is to distract the man who is selling. So he's overwhelmed with all of these requests. While that is happening, every boy who's in the shop is picking stuff from the table and putting in their pocket. I told you guys, I'm not like proud of it. I'm just saying it's an example. So don't judge me. If you hear your own now, maybe your own will be worse self. We never know, right? So that is like an idea of how denial of service attack works. Only this time around, the server, who is like the man in the shop, is flooded with requests. In attempt to respond to each of the requests, he's consumed and he may not have attention for every other service. Now, usually this person who is flooding the attack or flooding the request is normally an illegitimate person. It's done on purpose. The idea is to just hijack its entire resources. Remember, I said nobody attacks your system, attacks your laptop or your device because of the name it bears. It's usually because of the service. Why do they want to do that? Well, there are resources they want to use. Maybe, get your information or perhaps use your resources to send theirs. So that's how denial of service attack works. And then there's distributed denial of service, which is normally automated, in which case we have some bots, which is the case today. And with the incoming of AI, can imagine what we can do, write scripts and distribute it. And these scripts are just overwhelming a particular server. And the server is collecting requests from left, right, and center, and then is overwhelmed, and then legitimate users cannot use that service. Then there's also network access control bypass. Typically, every time we have a network, you want apart from identity and access management solution, there's also network access control, which can be a combination of lots of stuff. Could be firewall implemented there, could be access control list implemented there. Depends on the levels of access control you want to implement in network. Knowing that if you must come into the network, you'd have to come through that particular database and be checked, be authenticated. There is a way that that particular thing is also bypassed. There is what is called VLAN hopping. Remember, I mentioned before that if you have a good knowledge of network, it helps. So VLANs are like virtual networks, which are collections of either ports or services, that are allocated to certain users. So you group them into smaller manageable groups. So let me paint a picture for the benefit of those who don't know anything about VLAN. Imagine that you're in a house, right? And you have to share one room with 5 of your siblings, right? Of opposite sex. So you're a guy or you're a female, right? If you're a female, imagine sharing the room with boys. If you're a guy, imagine sharing the room with sisters, girls. Of course, the kind of traffic that all of these people generate by reason of their specificity, English, man, is not the same, right? So you would always have to struggle with using the room. Could be mirror. Let's even go to the other side. You keep a comb, you can't find the comb. You drink water and keep, like somebody say, drink water, drop cup. Somebody will take it, right? You have this biscuit you are chewing, you keep it with the hope of coming back later to chew the biscuit. Somebody takes it and eats it. Or you have this eye pencil, eyeliner, or hairbrush, or wig. Something, you just realize that every traffic of yours that is generated in that single room is going to be interfered with because you guys are all sharing the place and everybody has to use that place. That whole place is a domain. With respect to networks, we can say that the place is called a broadcast domain, right? Because you all share the place. Or it could also be referred to as a collision domain, which is contention for space or for bandwidth. Now, with that kind of environment, what you would long for is to have your own room where you can drop water, drink water, drop cup, and come back and meet the cup where it is. Now, with that, you can even leave your room, leave the bed undressed, or perhaps you can dress your bed. If you're the type that likes dressing your bed, dress it in the morning and come back and meet it the same way. But that is not going to be possible in that single small room, right? So VLANs is like the solution that supplies isolation of all of these specific traffic or specific human beings into single rooms, right? Unique rooms where they all stay. Now, the purpose of that is to ensure that everything that the guys, one of the first things you want to do is to separate the boys from the room. So you say, boys, go to your room, girls, go to your room. By doing that, you have separated them into virtual identifications. They are all in one house, but there's a room as allocated to the boys and the girls. So it's like traffic is all in one network, but then you've been able to virtually separate them or isolate them because of their specific, unique kind of traffic. Now, once those traffic has been identified, there's a need for every traffic generated from each of those rooms to have a tag. The tag identifies traffic coming from there. Why are we dealing with all of this? Is because this is where attacks actually occur. A good understanding of how these things operate can paint a picture. So when we're discussing how the attack happens there, you can relate with it. Now, VLAN hopping, which is the attack, is simply when somebody assumes the identity of all VLANs and then is hopping from one VLAN to the other. Now, that's dangerous, right? So it's like saying somebody carries a tag. The idea is that if traffic is leaving a VLAN, it needs to carry a tag. Right? The tag identifies that this is the VLAN or the network this guy is coming from. They are normally numbered. So there's VLAN 2, VLAN 3. VLAN 1 being the default. There's VLAN 2, VLAN 3. Now imagine somebody walking through a network and carrying, let's say you have VLANs 2 to 10, carrying the identity on them. This is how it works. Traffic arrives at VLAN 10. VLAN 10 accepts the traffic on strips it strips the label on that particular traffic and passes it on. Now, notice that if it has carried all VLAN 2, 3, 4, 5, 6, 7, 8, 9, 10 tags on it, it means that the first traffic, all the device needs to do is once traffic enters into a switch or the network, the first device which it enters into will search for the VLAN number. It needs to do that so that it knows where to send it. Once it enters into the place, the switch that is VLAN 10 will take off VLAN 10 tag and send the traffic through VLAN 10. Traffic arrives in VLAN 10 is appearing there with VLAN 9 tag. That particular switch will send it to VLAN 9. VLAN 9 will take out the tag and then it will send it forward to the next VLAN. What's happening in this case is that every device is making decision based on the tag which it is seeing, which is very dangerous. Instead of going to a specific place, traffic just keeps looping to the entire network. So that's one way that people can actually do that. And this can happen by people dropping information here and there. So let's start with the first one. Now, name resolution is one of the most fundamental aspects of network and operating systems and all their applications. Some of the name to IP address resolution technologies and protocols used to be, right? Let me not say used to be because some people still use this NetBIOS, and then there's LLMNR, then DNS. I'm trying to remember what LLMNR is. Can't remember it top of my head now. I think I've seen it somewhere, right? So, okay, so they both provide primary Microsoft host identification, right? Typically saying if you're part of a network, there's got to be a way that you're identified, right? And if there's no identity, of course, there's going to be a problem. It means that traffic meant for someone would never be sent to the person. I'm trying to remember. Yeah. I think, yeah, there. I think it's link multicast name resolution. Multicast. Yeah, NetBIOS multicast name resolution. They are all Microsoft's primary um, means of identifying hosts within network, and it's based on DNS protocol format. So here's how DNS works. I think I can use DNS to explain what is it link local multicast. Yeah, I think it's link local multicast name resolution. I'm not very certain, but that's what it is, right? Now, DNS, like I explained, let me paint a picture. You all have phones, and in your phone, you perhaps have phone numbers of people who you have saved. It will interest you if I pick your phone, how the names are saved, right? So you may see Ade Mechanic. You may have Joseph Plumber. Maybe there was somebody you met, and the reason for that is for security reasons. A lot of people don't say full names and designations in the event that it is taken, so that nobody actually does phishing with your phone or smishing, right? You may see Oche, ethical hacking. You may see somebody. Sometimes you may even save the person's name with where they work, right? Maybe or where you guys met. So if you met at the filling station, right? You can say something like James Filling Station. If you perhaps have somebody who sells you dogs, you may have somebody's name like Ilya Dog, right? But say now the thing is, the way the names, we may all have the same name, the same number saved in all our phones, but we save it based on how we can remember so that we can easily resolve searching for it. So the same vein, we have different hierarchy of this structure, and these hierarchies are based on some kind of how do I put it now? How do I call it now? Services that they give. There's education, there's commercial, there's military, there's for countries now we have .ng, .au for Australia, .za for South Africa, excuse me, .ca for Canada, and so on, right? So whenever I'm searching for a particular name, I type name, let's say yahoo.com or netacad.com or isoc.com or ncs.com or .gov or .net or whatever. Whatever I type is just a name. Now the systems would have to go and check a database somewhere, resolve that name that I've typed with the database that they have, which is based on the varying hierarchical records. And these DNS systems are linked with each other. So they help resolve these names. Just like how I may not know how, let's say maybe there's some James I'm looking for who fixes fridge, right? I don't know how you saved it. So no, I have a fridge repair on my phone. If I pick your phone and I search for it, I can't find it because I didn't save it. So except you tell me, oh yes, check for James fridge. right? And I'm able to identify that particular number. So that's how DNS works. So a Windows host trying to communicate to a printer, right, or to a network shared folder may use NetBIOS as illustrated in the figure. In this figure here, we have this is a printer, that's a host, and then it has an identity. So it's trying to reach this particular printer. Now, what is going to happen is there is a session that needs to be created between this guy and the printer. Please note that, of course, the printer is connected to the switch and the hosts are connected there. So there are chances that all of these guys, if I send the traffic to this switch, two things, two things will happen. Number one, the switch has a database of people who are connected. It's called the MAC address table. The MAC address table is the identity of everybody who the switch has identified that connects to it. Now, if the switch has the address of the printer attached to it, right, it's going to store it. Now, the switch actually deals with only MAC addresses. However, within the network, they have identities of their own self, right? So the host A sends the traffic to the switch, intending to send it to the printer. The printer will check its database and realize that, oh yeah, that printer is connected on 0/4 port on that switch. It will go ahead and forward it because it knows it. So when a switch knows the port that the device is attached on, it forwards it to it. Now, here's where the part where it gets a little bit tricky. When a switch doesn't have a record at all, it attempts to reach it by way and manner. So it would broadcast it, and that is called flooding. So the services that NetBIOS provides for everybody is for the purposes of name registration and resolution. There's also for the purposes of connectionless interaction. When we say connectionless, it means that the device is not present to respond to requests that I've made, and we don't have a conversation that tells it's ready or it's not ready. So I shall send it. Now, you can send a file to a printer, but there's no telling whether the printer is available or not. Then we don't have that level of overhead that is done within the network that decides to say, hey, printer is there, is ready, send now. The printer now receives, okay, I'm ready to print, and then send. Sometimes you can send files to a printer and they'll be queued up until when the printer is ready. So that kind of connection where we don't contact the destination to verify it's online and then connect to it is called connectionless. Okay. Now, please pay attention. We're actually dealing with how these networks work. Then we can now look at how attacks are done against them, right? Then it also has, in the event that there is a session that is active between any device within the network, NetBIOS provides a session service for the ones that are now connected, right? Those where it has to do printing. So, NetBIOS related operations use the following ports and protocols. So the ports are like shops. The protocols are like the rules that govern how to trade in these shops, right? So you have all of this TCP port 135, UDP port 137, UDP port 138, TCP port 139, TCP port 445. Now, all of these ports are used for these purposes. So if an attacker is going to be attacking, this is what it does. So Microsoft Endpoint Mapper is for used for client to client or server to client communication, ensuring that they are mapped, right? Like this person is communicating with this person now. This protocol for this port 135 TCP, this is what is happening right now. Then there's NetBIOS for the purposes of name service, just like the DNS is for 135. They'll have the datagram service. That's for the ones that are not connection oriented, meaning the ones that don't need to be contacted and reached. Then there's also the session service, which is for the purpose of maintaining each session that has already been established. Then there's the service message block, server message block, used for sharing files between operating systems, including Windows and Unix. So when you are sending file, what makes a particular system knows that, okay, this file is sent to so and so and received is based on this SMB. Now, in Windows, a work group is a LAN or local area network, peer-to-peer network that can support a maximum of 10 hosts in the same subnet and has no centralized administration. So that's what a work group is, right? Now, basically, each user controls the resources and security locally on his or her own system. So I have my firewall on my system based on the operating system and all, right? So a domain-based implementation is a client server network. So that's where I said the architecture of the internet suggests that there has to be a client and a server. So if I don't have a particular service, particular file or stuff that I need to contact who owns it. At that point, I'm a client, and the person giving it to me is a server. Okay, so once you have a domain, right? This is a combination of plenty work groups. That domain is based on implementation is such that we have a client and a server. And the idea is that the network supports thousands of hosts that are, scattered in a place. Could be an office. A good example would be like a campus, right? It makes a lot of sense when we explain using a campus. Could also be bank branches or company branches scattered within the state, right? Now, to be able to ensure that each of them are isolated and kept unique, and then traffic within them are specific to them, we have subnets, which are subordinate networks, networks that are part of a large networks, but are smaller networks. But of course, each network must have IP addresses identifying them. Now, a user with an account on a domain, right? Remember, a domain is actually a place where you have quite a number of work group, right? So a user with an account on a domain can log on to any computer system without having an account on that computer, right? These are things that are beginning to happen. Okay, I remember from way back when Windows XP was the thing, right? You could copy files from somebody's, once you guys are within the same work group, create a work group, add the person to there, and you can copy files from the person's using the network, drop it on your system, right? So we're saying that once you're within a domain, right, with the operating system that I have, by reason of how the network is structured, you are able to log in to any computer within the system, right, without having an account on that computer. Now, it does this by authenticating a domain controller. So there will be a domain controller. Who are you? This person is part of this domain. We share the same work group. We share the same domain. Cool. I can log in. So every now and then, firewall blocks. Like if you attempt to ping, the firewall would choose to not let it happen. Now, historically, there have been dozens of vulnerabilities with NetBIOS, SMB, and the link local. Let me get it. I think it's link local multicast name resolution. That's LLMNR. LLMNR. Link local multicast name resolution. A simple example: many users leave their work group configured with the default name work group. So by that, if any printer, right, is going to print, I can send a file from anywhere with, as long as we are connected within the same work group, I can reach you. This is part of why it is possible for somebody to log into your device. So it is very easy for an attack to be able to list all the devices within the work group. It happened one time back then where I work, where you know, we just typed a particular work group and noticed that there were different people's computers. You see like a pipe connecting all of them, right? How it's displayed. And we saw some music files there and we're copying it. Of course, except the person shuts the system down. So it is very easy for an attacker to enumerate the machines and potentially compromise the system by brute forcing passwords or leveraging other techniques. So brute force password is like just assuming that these passwords could be within a range of particular characters and then launch them all at the same time within a period of time. So a common vulnerability in link local multicast name resolution, that's LLMNR, involves an attacker imitating or assuming to be an authoritative source, meaning what makes your domain name resolution work is that some person has been given the authority to, based on the hierarchy. It has the structure of being the one to resolve. So when requests go around and they talk to each other, it is resolved. Let me also try to paint a picture with respect to how domain name resolution works. Have you ever gone to a shop to buy something? Sorry for the Igbo guys who are here. Don't be say I did beef now, but I like you guys' style. No Igbo man in any shop will ever tell you he doesn't have what you're looking for. He will tell you did the other shop. You go to the other shop and get it. Now here's what you'd realize. The cost of what he's bringing to you would increase by at least, 100 naira or something. He needs to actually get something for that job he's doing. So once you come to his shop and you ask for, let's assume that you're looking for black jeans. And everything that is there, he'll first of all show you the jeans. Oh, God, this one are black, and not be black. No, this not be the black one they look for. Oh, okay, you mean this other black? Okay, wait, make I go to the other shop, go bring her. You tell you to wait. So you go to the other shop. That's like what the domain name system does. They are like servers who have authority, right, as regards a repository of names, and they can resolve based on what you bring. So when you bring an IP address requesting for this particular, bring a name, sorry, requesting for, what the is it, what is the, how do I put it now? The I wanted to say commensurate, but it's not commensurate. Once you type a name, right, there's always what's that word now? The pair. It's not a pair, sha, but there's every name has an IP address, right? IP address name, IP address number. I don't know what I'm talking again now. But typically, there'll be a name and the IP address attached to it, right? So it will always, in the case of the link local multicast name resolution, a weakness that exists there is that anybody can actually imitate being authoritative source for the name that you're asking for, right? So it will respond to any request that is made. And it does that over port 5355, right? And responds. And typically, those guys don't have a way of identifying what it's looking for. Is looking for a resolution. So if somebody provides it, it gets it and then it moves. So the attacker basically would poison the database, the service, to manipulate the victim system. If the requested host belongs to a resource that requires identification or authentication, then fine. The username and the NTLM version 2 hash are sent to the attacker, which is the name, the network chai, the name of this particular system, which is the username and password or the identifier, actually are harvested. The attacker can then gather the hash sent over the network by using tools such as sniffers, and there are quite a number of those sniffers. Typically collect the data and then, of course, use a tool to de-encrypt it. Subsequently, the attacker can brute force or crack the hashes, do that offline, get a plain text. Now he now knows exactly how to log in going forward. For several tools can be used to conduct this type of attack, such as NBN spoof, Metasploit, and Responder. Metasploit is one of the most popular tools and framework used by penetration testers and attackers. It's very popular, right? It discusses a distribution of Linux that contains a lot of attack tools, or is it attack tools I call? Yeah, attacking tools, pen testing tools. Another open source tool that is very popular and has even been used by malware is Puppy. Puppy is a Python-based cross-platform remote administration and post-exploitation tool that works on Windows, Linux, Mac, and even Android. One of the most common mitigation for these types of attacks is to ensure that you disable NetBIOS and link local multicast name resolution in local computer security settings, or to configure a group policy. Now, of course, group policy indicates that if I belong to a particular group, naturally, right, if you have an operating system that has firewall installed, or have firewall feature activated, the natural behavior of the system is that regardless of the group it belongs in, it doesn't accept traffic coming from outside a group or outside that system. So you can actually add your system to a particular group policy and indicate what you don't want. Any form of traffic must be like a response from inside. Is a standard network, standard security posture where traffic that is origin or the source is from outside a domain or outside a group or outside what you consider as inside is not permitted in, except of course the response to traffic coming from outside. All right, so if you see a 0 for the value of that key, you know that the LLMNR is disabled. Okay, so to be able to edit that, one of the common techniques for poisoning this LLMNR is to monitor the registry key, which is the HKLM software policies Microsoft. So that's where the policies are contained. So if it is being changed, typically you're advised to just change to 0. We'll look at all of those as we move. Now let's look at a brief example of external blue exploit in Metasploit, as shown in the figure. I'm in the process of setting up my system for our labs that we're going to be doing at some point. I won't do all. I'll pick some of the labs and deal with those labs. So this is like a brief explanation. Now, the use you'd see here, right? This is the Metasploit device we're on. I don't know how bold this is on your system, but there's a command there which is use exploit /windows /smb /Microsoft 17 underscore 010 underscore eternal blue, right? Is a command, right? Hit the command, it assumes that particular directory, right? So you have the show option. It gives you all the configurable options of external blue exploit. So external blue is the exploit, right? This is the exploit, and this is done in Metasploit environment. So once you type that in, at the very minimum, what you see would be your R S hosts, right? Yeah, there. So is it required? Yes. Target hosts see this particular site. This is a link for the Metasploit information, right? Where is a framework using Metasploit. So at a minimum, the IP address of the remote host and the IP address of the host that you would like the victim to communicate with after exploitation must be configured. And then to configure the R host, use the set. So we set our host, which is here. That's the remote host. Set it. So the R host is your remote host, and then the L host is your local host. So typically your R host is the person that you want to attack. Then the L host is the place from where you are launching the attack, right? Now to configure the local host, use the set localhost command and then indicate the IP address. So here, when identified here, this is the guy we're attacking. This is the person from where we're launching the attack. So this could just be an IP address. So in case the traffic is going to be encapsulated for identifying who is sending what, it shows this particular system, this IP address 10.10.66.6. After the exploit is run, right, Metasploit executes the exploit against the target system and launches a Metapreter session to allow you to control and further compromise the system. So it's typically giving you an access to the meta. Meta is an interpretation, is an inter. So Metapreter is the platform that interprets the meta information, which is what you don't see. Meta information is what is not very visible to the eye. So SMB has historically suffered from numerous catastrophic vulnerabilities. Just explore the dozens of well-known exploits in the exploit database, which is in exploit_dbm.com, right? Let me try to put that in that place and identify the exploits that are there. So you perhaps just search for them and look at what we have as the database of all the exploits that have actually occurred. So let me put that. I've just dropped that in the group, right? Exploit-database.com just gives you a database, or -db.com gives you a database of all potential exploits that have actually occurred, right? So you can, by using search exploit SMB command as shown here, right? So this is in our Kali, right? When we search this, it gives a detail of the exploit. These are the titles: there's Apple Mark, the Cyber Ops Scanner, Ethereal OX, and all of these are all the attacks. And these attacks happen here on localhost. This is Windows, this is Linux, this is multiple remote devices. One of the most used SMB exploits in recent times has been the Eternal Blue exploit. Successful exploitation of Eternal Blue allows an unauthenticated remote attacker to compromise an affected system and execute arbitrary codes. This exploit has been used in ransomware such as WannaCry and Yeta, and has been ported to many different tools, including Metasploit. So a lot of these attacks can happen. You know, we said something, somebody was attempting to ask a question yesterday whether I should show you how attacks happen, and then I like what one of you said, say, please do it ethically, right? So the safest way, honestly, is to build your lab and launch all of this. So the lab for this guy is to, launch a NUM for Linux and exploits capabilities, identify computers with SMB services that are running, use NUM for Linux to enumerate users and network file shares, then use SMB client to transfer files between systems and see how these files are actually transferred. So it's a lab. There's a lab manual for it and the details of how that happens. So let's look at DNS cache poisoning. So this is another popular attack leveraged by threat actors that involves the manipulation of the DNS resolver cache through injection of corrupted DNS data. So simply put, the DNS is a server that gives services of resolution of names. All I need to do is to perhaps just overwhelm it, be able to inject information that is not correct, and it's added as part of the database, right? And so that's done by forcing the DNS server to send wrong IP addresses to the victim and redirect the victim to the attacker's system. Now, DNS is very important, very, very important. When you do your configurations of, say, DHCP, for example, there are certain identity, especially once a device in the network requires to get identity dynamically. That device is subject to whatever the dynamic system gives to it as its identity, right? So if it's going to give it an IP address and also tell the device who the default gateway is, right? And then also tell it who the DNS server is, which is very important, very, very important, because without the DNS, most names that people are typing in the network, right, and they hope to get to might never be resolved. So it's quite very, very, very important. DNS issues can actually ground the whole network for like the whole week or a whole day. Okay, so typically what happens here is that this is the victim, right? So I'll send a request to that. I poison this database. Once it's been poisoned, the information waits. The moment I can just maybe the site is let's say okay, let's put it this way. The art of hacking, right? .org is what I've injected into the DNS server, the database, such that that information is corrupt, but a client, right, who is wanting to go, let's assume that the site I'm trying to spoof is perhaps, let me see what I can do now. Okay, the art of hacking. I'm trying to see what I can change there, right, that can poison. Let's say, so let's say the THE, I change it to D, letter D, right? It's in the database. And it's now resolving the IP address, resolving to the IP address of that same site. So once the client sends the request to the DNS server, of course, the attacker has poisoned the database. So the final thing I want to do is to just ensure that I hijack the victim, right? The attack is pointing to me. In the database of the DNS server, the site that I've injected contains my address, the local host, contains my address as the destination. I can even create, it could be twitter.com, right? Can actually even, sorry, okay, x.com, I think it's still, I don't know if, I think they still carry Twitter, x.com, or perhaps even facebook.com, could be tiktok.com. And then I'll change the characters to look somewhat like what actually exists. However, the IP address is not going to be pointing you to the original TikTok server or Facebook server. It's going to be pointing to me. And my plan is just to hijack you. So typically, once I've poisoned the database of the DNS server and you make a request to the server responds with my IP address. Remember, the job of the DNS is resolving names to IP addresses. So if the database has been poisoned, right, the cache that he has been poisoned, which contains a wrong IP address, the IP address will be pointing to me, and that way I hijack that particular client. Somebody's asking a question. I've joined using my Windows, but I'm unable to hear anything. So, I don't know how to handle that one for you now. The record will be available so you can hear everything by then. If you can hear me, that is. It's network. Don't worry, that's what happened to me earlier. And I'm hoping this actually doesn't even log me off, right? I'm trying to just talk in a hurry, and it's affecting my delivery. So typically, database poisoned, client, who is now the victim or the targeted victim, goes to the database to request a particular IP address, and the IP address turns out to be the poisoned IP address. Once sent back to that device, the device will now go ahead and maintain a communication with that site, and then it's hijacked already. So this is how the mechanics of DNS cache poisoning works. Okay. Now, so the attacker corrupts the data of the DNS server cache to impersonate the artofhacking.org website. Before the attacker executes the DNS poisoning attack, the DNS server successfully resolves the IP address of the attack of the artofhacking.org to the correct address of 104.27.176.154 by using the ns lookup command. After the attacker executes the DNS the DNS server resolves that now that IP address of that site has changed from 104.27.176.154 to 10.2.3.4. Now, so the victim will go ahead and send a request to the DNS server, right? And its plan is to obtain the IP address of that particular site, which is the artofhacking.org. The DNS server, which has now been, the cache, which has now been compromised, now has a different IP address for that particular site. It will reply with the IP address that's been compromised, which points to the attacker. The victim will go ahead and send its typical conversation. Remember, I told us that every protocol that's existing that makes the internet or network possible for interaction has its own rule. So if it is HTTP, we have GET, we have PUT, we have PUSH, and the rest of it. So GET normally is a request to get a particular site. So once the victim now, which is now the compromised victim now, right, or the target, sends a GET, I want to download a particular thing, to that or purported DNS server. Of course, this time around is going to the attacker. The attacker, who is now impersonating the artofhacking.org, would send its information. And by doing that, it could be a script, it could be an injection, it could be whatever. It's now compromised. And from that point on, it's hard. Okay? So let's look at SNMP exploit. SNMP is a protocol that many individuals and organizations use to manage network devices that use, and that SNMP uses port 161, UDP port, right? Now, in SNMP implementation, every network service contains an agent. And that agent connects with an independent server, right? Which is also known as a manager. When we say as independent, it's usually for each network. SNMP server will be for the network, and it keeps a database of everything that every device within the network does, every administrative task. So an administrator can use SNMP to obtain health information and configuration of a networking device, meaning the status, when it booted, what issues it had, all of this are sent to the SNMP, because we can go back there, retrieve it, and tell the state, the behavior of these devices. By the way, all of this information that will be stored in the SNMP server are normal information that, as your device is booting, right, they are stuff that you can see on the screen. So what we want to do most times is say, look, I may not be there when this information is actually passing by. What I want is to get a snapshot of this information and keep in a repository somewhere. That's the SNMP manager, or what you call the server, which is normally what you can install. Very lightweight. You can install on your PC, and your PC can serve as an SNMP server. It installs in your C, right? As an SNMP cell, right? So what happens is all of this information that scrolls up your screen can be mirrored to the SNMP server. So some of it contains health information, right? And perhaps also configuration information of a networking device, right? So, so what the administrator can do is that he can just attempt getting that information to change the configuration and to perform other administrative tasks. He can do that, drop it down, then the device can go ahead. Now, a very attractive way for the attacker, right, is that he now knows that these guys have a service running in the network, and the service is on port 161. The service is for SNMP, which is simple network management. So the rule requires that there must be an agent, then there must be a manager. So the manager is the database. This agent is any of the devices in the network, and they send their information to that particular server. As an administrator, I can access the manager, retrieve those information, and work on it. So nice. So that means somebody can access that server and retrieve the information. So this is very attractive to the attacker, because they can leverage the weakness of SNMP to perform similar actions in a malicious way. The same way the administrator is going to go into request information, I know that every now and then there can perhaps be like a backup, right, on those SNMP systems, and perhaps somebody can retrieve that for the purpose of updating the system. So let me just influence that information in the server and poison it. So there are several versions of SNMP, but the most popular one today is SNMP version 2 and SNMP version 3. Version 2 uses community strings, which are passwords that are applied to a networking device to allow an administrator to restrict access to the device in providing read-only information, right? And then it can also give you opportunity of read-write access. So what you want to do is to say, typically, once you are reading from the manager, just once you are accessing the manager, you only have opportunity of viewing, you just read. But you don't have the opportunity or the privilege of adding to it or writing to it. Right? So the managed device information is kept in a database called the MIB, not Men in Black, or Management Information Base. So in that management information base, I have two administrative restrictions. One, read only or read and write access. A common SNMP attack involves an attacker listing SNMP services and then checking for the configured default SNMP password. Then I can spoof or launch an attack and go ahead to attack it. So unfortunately, this is one of the major flaws of many implementations because many users leave weak or default SNMP credentials in networking devices. SNMP version 3 uses usernames and password, and it is more secure than all previous SNMP versions. So here's the catch. All of the versions that are now being deprecated were the secure versions at the time they were released. So the only thing is they never hack them yet. So they would always do that. Attackers will perform dictionary attack, which is like a list of potential passwords and launch it against it and hope that one works. Or I can also do brute force attack, which is, of course, do the same thing, dictionary, but launch it in a more forceful way against the SNMP version 3 implementation. However, a modern and security implementation involves using net configuration or net conf with newer infrastructure devices such as routers and switches. You can leverage Nmap scripting engine. We did that, I think, module 3 or so, using Nmap to check one or two services that are available. If you remember, after launching it for a particular site, we saw the number of ports that were open. So you can list these ones, also tell you which of the ports that are enabled, and then it's able to tell which of them can attack. So in Kali Linux, the Nmap scripting engine are located in user or in /user/share/mmap/script by default. So you see it here. Okay, these are where the scripts are kept. So the figure shows the available script for this particular Nmap scripting engine in the Kali Linux system. In addition to NSC script, you can use the SNMP check tool to perform an SNMP walk in order to gather information on devices that have been configured for simple network management protocol. So here are some of the exploits. Attackers may leverage insecure SMTP, simple mail transport protocol for mails, right? There's IMAP, Internet Messaging Access Protocol. There's POP, which is Post Office Protocol. There is SMTP, which is Simple Mail Transport Protocol. All of these have they have ports that can be attacked and be exploited. So in every mailing system, there are three structures. There's the mail agent, user agent, there's a mail transport agent, then there's the mail delivery agent. Right? And all of these guys use different ports for this their service. So attackers may leverage insecure SMTP server to send spam messages or unsolicited messages. So spam messages can be classified in lots of ways, depending on the configuration of the service provider. More or less, spam is unwanted mail, mails that we don't want or mails that we didn't subscribe to. So there's a default setting for most of the mails. Once the mail exceeds a certain size, it is considered spam. Could be legit mail, but it's normally kept in the spam. So you can go back to the spam box and check. If it's a mail that you constantly have to interact with the sender, you can, click on it and allow it. From that day, it no more belongs spam. Okay. So SMTP is a server-to-server protocol, which is different from client-server protocols such as POP or IMAP. Before you can understand how to exploit email protocol vulnerabilities, you must familiarize yourself with the standard TCP ports used in the different email protocols. 25 is SMTP, the default for non-encrypted communications. Then the ones that have been registered by IANA, right, for SMTP over secure socket layer, SSL, is SMTPS. Just like how you have your HTTPS, right? So SMTPS is on port 465, right? So it's been deprecated in favor of the new one called Star TLS, Transport Layer Security. As port TCP port 587 is for secure SMTP for encrypted communications as defined in request for comment 2487. So request for comment is a document that is built by professionals who actually review technologies and post in some challenges or findings for the purpose of working on it and getting it better. So each time a protocol is discussed, right, is a number that is assigned to the conversation that happens. So that number is what you see here. For SMTP, it is 2487 for secure SMTP. And then it's within the range of RFC. When I started out, I downloaded RFC document at one point. By the next week, I noticed that what I had was already obsolete because these documents are reviewed on the go. Some of them actually are open to some people. Some of them are within closed groups. You can be invited to say, hey, we're working on this. So they get techies, they get users, they get administrators, programmers, network guys, security guys, all work on this. And then they view this particular technology from different perspectives. And then their submissions are used and then they are built into the document that is now made public, is made a standard document. So RFC is a standard document. So for SMTP or secure SMTP, the document for it is 2487. So there's a mail user agent, right? And it uses TCP port 587. And then there's email submission for TCP port 25 in some implementations for SMTP. Then port 110 is for POP3, non-encrypted, and then port 995 is encrypted. So it's like POP3S, right? Or SPOP3. Then there's IMAP, or let's put it this way, POP3 SSL or TLS. Then there's IMAP default, which for non-encrypted communication is 143, and then there's 993. So what I would expect you to do is perhaps go and read about this. It's a long read, right? Read about it, understand what all of these things are, and then see how it happens. So there's what is called the SMTP Open Relay. This is a term that is used for an email server that accepts information that is sent to it and is sending it somewhere, right? So it is poised to be like a transit point for mails that are sent through it. So an email server that accepts and relays emails from any user, right, to certain servers. It is possible to abuse these configurations to send spoof email, spam phishing, and other email-related scams. Nmap has a script, right, to test for open relay configurations. So this is what that script is. Remember that all our scripts in Kali are stored in /user/share/mmap/scripts hash, right? So this is script SM open relay. Then we run this engine against that particular open relay, which is resident on 10.1.2.14. So he starts it and tells you, hey, I'm doing a scan for this particular IP address. The host is up, right? It took me this amount of time to get to that device. The state of the port as it stands right now is that it is open and it's running on port 25, which is the TCP. The service that is running there is SMTP. So this is what we have as an output. SMTP open relay. Server is an open relay. So we've done 16 tests, and out of 16 tests, it returns saying that it is doing that. So after the Nmap NCE is done, it says, look, Nmap is done. We found one IP address, one IP address, and it is attached to one host. And this scan was done in 6.82 seconds. Wow. Scripts are crazy. Well, in the end, hopefully we get to use the scripts to create a lot of stuff. So remember that the idea here is simply saying that the server has the ability to do relay. Now, how can I take advantage of that? So typically, examples of commands that can be useful for performing a security evaluation on an email server. There's hello, right? Normally, this the traffic that initiates conversations with an email server, right? So in this case, an example here is say hello 10.1.2.14. Now, hello is, I think, is an acronym. I think so. Not sure anymore. Yeah, it stands for something. I can't remember. I'm cracking my head. Typically, don't forget. Let me go ahead. Usually all of this is actually acronyms. Okay. Uh, See host. I don't know if you remember. Let's leave it. So typically, it's used to initiate conversation, right? So there must be a target device, of course, an IP address and identity of it. So then there's LO, used to initiate a conversation with an extended SMTP server and is used in the same way as hello. So this is the structure of conversations that happen. Remember, I mentioned that for whatever service that's available in any network, there is a protocol. That protocol governs how the conversations go. Now, this is for mail. Why are we disturbing ourselves with it? The attacker can exploit these conversations and tweak it to compromise the server or the service, as it were. So that's why we're dealing with this way. Then there's the start TLS, which is used to transport a transport layer security connection to an email server. There's the RCPT used to denote the email address of the recipient. There's data itself used to initiate transfer of the content of an email. There's reset or RSET, which is used to reset, cancel, or end an email conversation which is ongoing with respect to whether it is a hello, whether we are sending data. So then there's a mail used to denote the email address of the sender. There's quit, which is used to close the connection. Not the same with reset. Reset is restarting it or canceling it, but quit is to end it, right? Then there's help used to display help menu if they are available within the service. Then there's auth, which is authentication. There's verify or VRFY, used to verify whether a user's email mailbox exists. Then there's EXPN, used to request or expand a mailing list on the remote server. Now, the figure that we have below shows a telnet session. Now, please note, wherever you are, whatever network thing you are doing in this life, ensure that telnet is thrown out because it is not safe. Why? What do you say? Why do you say telnet is not safe? It's a port that is in use, right? It was actually originally for remote access to devices, but then it gradually became weak in the sense that it doesn't encrypt whatever is passed through that particular port. So ensure that you don't use it. However, the figure shows an example of how you can use some of these commands to reveal email addresses that may exist in the mail server. In this case, you connect to the email server by using telnet followed by port 25. So I'm attempting to connect to that particular port. In this example, the SMTP server is using plain text communication over TCP port 25, meaning it is using 110. No, not 110. 13, sorry, where is it? 25, sorry, port 25, unencrypted, right? So then use verify command with the email address to verify whether the user account exists on the system or not. So here we have, this is telnet. So it's telnetting this particular IP address. This is server. I'm telnetting this server, and I'm telnetting, hoping to get port 25. So it says we're using plain text communication over TCP port 25. Trying that particular host, then it's connected. I'm connected to the host. So whatever I see from here now is the server, right? Or the service that is running. And here we're verifying system. And we have 252, right? Systems, verify the admin is there. Recipient address rejected, user unknown in local recipient table. Verify the root is present, and this is root. Verify Omar, who is the guy that we're working with in your curriculum. If you observe, Omar is this guy, he exists. So these are users that exist in the place. So I can run this and be able to tell who to exploit. So there's the SMTP user enumeration or enum, which is installed by default in Kali Linux. It enables you to automate those information gathering steps, right? And it has different switches. The switches are all of these letters that which indicates to you in the event that you type a command and you use that particular switch or the particular character, it tells you what's going to display. Okay, so you explain how to use the tool. So this figure shows how to enumerate. So in this case, this is on Kali, SMTP user enumeration. Switch M. Let's go back and see. That's MU, right? So M is, in this case, Capital M, capital letter M is mode, method to use for username guessing. So I'm asking that I want to use M, and what the method here, the mode here in this case was what? Verify. Okay. So based on what we have here, the mode here could be expatiate, verify, or it was RCPT. I think is receive, right? RCPT. I saw it somewhere. I may not be here. Yes, there. Used to denote the email address of the recipient. So I'm trying to find out the email address. So typically, the command here says, I'm using that command, SNMP user enumeration, display, I'm verifying this user, Omar, -T. I'm sending a ping. What's -T now from the output? -T here, the switch -T here is host server, host running SMTP services. So I want to verify if this particular guy is running SMTP on this address, right? So it begins to scan, start enumeration, begins to run. Say the mode here is verify. Workers processes are 5. This particular guy is running 5 processes. The target is 1. Username account is 1. The target TCP is 25. Query time is 5. Timeout is 5 seconds. Target domain. So it begins scan. And after scan is complete, right? And it has one result. One result says one query in 1 second. So the one result reveals that that guy exists and is running that service. Right, so it is possible to take advantage of exploits that have been created to leverage known SMTP-related vulnerabilities. So here's what we have our search exploit. This is on Kali Linux. So we're searching search exploit SNMP. This is a list of the exploits that have taken place or been created that we can use. And they're all listed here. This is on Kali. So everything we're talking is just explaining what they are, right? Then there's FTP exploits. Attackers often abuse FTP servers to steal information. So what we used to have back in the day for FTP protocol doesn't use encryption to perform any kind of integrity validation. You just click on it, download file, you download, or you can upload file. Recommendation that has been proposed, right, dictates that to implement a more secure alternative, implement FTPS, which is File Transfer Protocol Secure, or SFTP, which is Secure File Transfer Protocol. So the both protocols are use encryption to protect data. However, some implementations such as Blowfish and DES. DES is an encryption technique, they are weak, they are old, right? And they use weak encryption ciphers or algorithms. You should use strong algorithms. Talked about this, I think, some few days ago. AES. AES is a more encrypted, a more secure encryption, and AES is actually most encryption today carry AES is actually advanced encryption system standard. Sorry, it's an algorithm, an encryption algorithm that is secure, right? And is actually even implemented in a lot of devices today, also in wireless. It is based on the review or the revision done by I think is Institute of Standard and Technology, NIST, right? That much I can tell about it because there's a topic in cybersecurity or cyber ops or network security that captures cryptography. This is mentioned there. So it's become the standardized advanced encryption standard. Is a standard today, right? I think is a symmetric encryption technique. So you should use stronger algorithms. That's bottom line what this means. It's more as it is today, that's the guy. Maybe in the next 2 years, we may have something better. So similarly, SFTP and FTPS servers use hashing algorithms to verify the integrity of file transmission. So hashing is simply adding a cipher to data to ensure it is unreadable. So that's what the algorithm does. Sometimes a fixed value, sometimes it's not, depending on what it is. Best practice calls for disabling weak hashing protocols such as MD5. MD5 is a message digest 5. Then there's SHA, SHA is secure hash algorithm. Those ones were the earlier ones. I think as at 2010, they were Gengen, especially SHA. SHA 1, SHA 2, right? Were the Gengen ones. But as it is today, they are being deprecated, and the advice is in the event that you have to use encryption for hashing, please use the stronger ones, such the ones like SHA-2 and SHA-512. In addition, FTP servers often enable anonymous user authentication, which an attacker may abuse to store unwanted files in your server, potentially for the purpose of exfiltrating those information for later. They can store it there pending later they can come and get it. For example, an attacker who compromises a system and extracts sensitive information can store that information as a stepping stone to any FTP server that may be available and allow any user to connect using the anonymous account. Okay, so I remember there was a time we deployed FTP server in a place of work, and it was open to everybody. People could go there, create folders, and drop their stuff there. All you need to do was just to have, I think there was a password. Password was very basic. Just drop files there. So the idea is that if you have an FTP service running within your enterprise or your environment or the person for whom you're working, it could be like a place where people are storing stuff, hoping to come and pick much later. All right. So this figure shows a scan using mmap against a server with an IP address of 172.16.20.136. That server is running FTP. Nmap can determine the type of version of the FTP server that is being run here. In this case, it is version 3.0.2. So let's look at this. So Nmap, this on Kali, Nmap, we're running a scan. We're running a scan on 172.16.20.136. Oh, please note, in the event, if you have Kali installed or any of the Linux distributions, if you have it installed, and you have a command, let's say from a lab manual that you need to input and you don't know what that is, you can go to your device, your operating system, and man, right? You man it. Man will be the manual. You read the manual for that particular thing. It lists all the switches. Like in this case now, I don't know what this is. Perhaps you can even look at it from that particular, I think here, yeah, I think it is here. Well, this is for SMP, but these are actually options for this particular. Well, they are different. This verbose V, capital V. That means detailed. This is for SMTP. I don't have that of FTP. Okay, so what I'm trying to say is that this particular switch here, right, indicates what you are wanting to do, because you're telling Nmap to run this particular service on this server. In this case, we are told here that is running a scan against a server. Okay, so the Nmap discovered that this particular server, after running it, right, the Nmap scan report for this particular device, the host is up. This is how many seconds it took to get to the device. It is not shown. Is the number of ports that are closed, 997. The state of the port as it is right now is the port is 21. It's a TCP port. The state of the port is open. The service that it is running is FTP. Then the version here is version of the FTPD. FTPD here is the FTP daemon, right? And it's running a version 3.0.3. So the figure below shows how to test for anonymous login in an FTP server by using Metasploit. This is on Metasploit. So the command here is use auxiliary/scanner/FTP/anonymous, simply saying, show me all of this. Show me any scan and show me any FTP service for anonymous login. So it runs a scan and identifies that, hey, this is a remote host. Remote host here is, okay, great. So once I enter that, it asks me to set the remote. The remote host is, of course, I'm running for scan here. So identify the server here is 172.16.20.136. So that's the same server from earlier. I'm running a scan to find out whether there are any anonymous login available for this particular FTP server or service running on this IP address. So it goes ahead to run this guy, hit enter, and then it begins to exploit. It finds that this particular guy, 172.16.20.136 on port 21, right, is running anonymous, and the right that this guy has is read, can only read. So this anonymous guy can only read, he cannot write. Okay. So in this example, the server is using a version FTP VS. Okay, the version here is FTP daemon. And thus the configuration file is located at etc/vs-ftpd.conf. It's a configuration file, right? The following are several additional best practices for mitigating FTP server abuse and attacks. You have a question, Suleiman? Okay, no, there's no question. Okay, all right. I thought you were going to ask questions. So, these are ways to mitigate FTP server abuse and attacks. Number one, use strong passwords and also implement multi-factor authentication. The best practice is to use good credentials, right? And then you can decide to say, you know, like one of the credentials, like I said earlier, I think for the purpose of being able to remember, or maybe making clients or staffers to remember, is you always tell them to use maybe sometimes first credential of the first name and the last name, or last name with the first credential of the first name, stuff like that. So use the best ones. When possible, use two-factor authentication for any critical service or server. Implement file and folder security, making sure that users have access to only the files they are entitled to access, right? Use encryption for traffic that is at rest, not traffic in transit, okay? That is, encrypt all files that are stored at the FTP server. They should all be encrypted. Lock down administrative accounts. It should not be available to everybody. You should restrict administrators' privileges to a limited number of users and require them to use multi-factor authentication. In addition, do not use common administrator usernames such as root or admin. Okay. That's been the standard before, but found a way now. So you can decide to use a different name. But we all know who, maybe, I don't know, maybe a role-based name. Keep the FTP server. Keep the FTP secure or secure FTP server software up to date. A bulk of the problems that people face as regards exploits start with not having up-to-date softwares. One of the issue again is that a lot of people actually get free stuff. So updating it becomes an issue because most times once you update, then will catch you, right? Then, okay, so we don't have one in the country. Use the US government FIPS 140-2 validation encryption ciphers for general guidance on what encryption algorithms to use. Keep any back-end database on a different server than the FTP server. Require re-authentication of inactive sessions. So it shouldn't be open-ended. Naturally, if the FTP server, if the person is not downloading, the person refreshes the page, it should be that the session times and the person is prompted to log back in with the credentials again. Okay, so these are ways to mitigate. Now, all Windows versions store password in what is called store password as hashes in a file called SAM, Security Account Manager. Now, for those people who use Windows, right? I'm very sure that you have how do I put that? Users, right? And perhaps because we don't navigate operating systems too well, for people who have done some courses under operating systems and perhaps hardware, you might have come across some of these things. So let me attempt to shed some light, right? So for Windows operating system, there are databases, right, inherent in each operating system for different things, policies, you know, how different devices behave and all the rest of them. There's one for password, and that is stored in the Windows operating system. And what this particular file, which is a security account manager, things like user accounts, the security descriptions for each of the user, and perhaps maybe if there are groups, right? It requires a particular database to handle all of this because typically like any device that requires logging in, there must be a database that checks what you're imputing as login information. If it tallies or matches, then it can go ahead and allow you, which is more or less some like basic identity and access management level. And this happens on operating system level. So most of the operators, especially Windows, for Windows we have SAM. SAM is the database for Windows operating system, and it stores security related information. Essentially, that's what it does. So the operating system does not know that the actual password or knows what the actual password is that is stored in that particular place. It just stores them in hash. So instead of using a well-known hashing algorithm, Microsoft created its own implementation that has developed over the years. And what they have is the new technology LAN manager. Okay. And is used for authentication, the NTLM. It has two versions. There's version 1 and version 2. So coming from Windows 2000, right? Windows had used Kerberos. Sounds like one name in Kaduna State, right? So it has its weaknesses, right? What's it called now? The new technology. SAM has its weaknesses. It is usually a target. Knowing this now, right? Knowing this, an attacker develops a tool to be able to retrieve all the credentials that are stored there. An attacker may use what is called, I think it's called SAM dumping, right? So typically it just copies the whole file from there, then goes, pastes it somewhere and decrypts it, right? And so it's been improved on with recent Windows operating system. I think starting from Windows 10, it's been improved on. Windows 10, Windows 11, and the rest of them, right? It's been improved on for further protection. So they have they have Windows Defender credentials that guard against unauthorized access, right? So that's what's been done for that. So since 2000, what they were using was Kerberos. Now, the new technology LAN manager may still be used when the client is authenticating to a server via IP address, or if a client is authenticating to a server in an Active Directory, right? So basically, it relies on the new technology LAN for new technology LAN manager for um, um, inter in how do I put it now? I don't use interforest trust. Well, typically moving from one directory to the other directory checking. So in addition, the new technology LAN manager might also still be used in client if the client is authenticating to a server that doesn't belong to a domain, or if the Kerberos communication is blocked by a firewall. So what is a pass the hash attack? Carry the hash, pass them to me. Now, normally because passwords cannot be reversed, that's when they are hashed, right? Remember, the hash is taking a plain text, then taking a particular cipher and adding the cipher to it. Once you add the cipher to plain text information, it becomes a hash version. So instead of trying to figure out what the user's password is, an attacker can just use the password hash collected from a compromised system, then use the same hash to log into another system or system server. So once the hash works, it keeps passing it. So Windows operating system and Windows application ask users to enter their passwords when they log in, standard. That's if you created that. So the system will convert the password into hashes, in most cases using application interfaces. API application programming interface is called LSA logon user. So a pass the hash attack goes around this process and just sends the hash to the system to authenticate. So typically it's on your system. Each time you log, it copies all of this stuff and then sends it to a database where it can apply a particular decipher to unhash it. So you'd realize that sometimes some systems don't even list out, once you type in your password, it doesn't list the number of characters that are there. So that's one way to mitigate against it. So what is Kerberos? So Kerberos is an authentication protocol defined in Request for Comment 4120 that has been used by Windows for several years. and by numerous applications and other operating systems. So Kerberos it has three basic elements. There's a client, there's a server, there's a key distribution center, or what we call a KDC. And what they are used for are authentication and ticketing. Okay, so it's typically authenticate you once you are original, then it grants a ticket for whatever action you're going to do. So these are steps for Kerberos and the authentication. The client sends a request to the authentication server within the KDC. Let me pause. For some reason, it sounds like what we're talking about right now is like, is it needed? Well, remember, we are looking at the natural behavior of these systems and understanding how these guys behave. It prompts the attacker to launch a tool or an exploit for the specific weakness he's trying to look at. So that's why we're taking the pain to look at all of this. And so it can be hectic and stressful. This is why I was telling us that, except, of course, somebody gives you a tool and say, use this tool. This is what this tool does. This person is throwing you into some serious trouble. Typically, it's good to understand how these guys operate so that once an attack occurs against it, it's good. This is not too different from what, just imagine that you're a vet doctor. And vet doctors, if you're a human doctor, like a human being, like, is it human doctor they call them? If you're a doctor, the patient can actually tell you, this is what's happening to me, this is what's happening to me. But in the case of vet doctors, you'd have to now rely on certain signs and symptoms, and certain displays to determine that, oh, this is what is happening to this particular animal. So that's what we're trying to do. Assume that we're vet doctors of the internet or the network, looking at the symptoms that normally would exist and then see how somebody can attack it so that the network doesn't die. So looking at how Kerberos authentication works, number one, a client sends a request to the authentication server with the key distribution center. Now, the authentication server sends a session key and a ticket granting or a ticket grant, TGT, a ticket granting ticket that is used to verify the client's identity, saying, oh yeah, it's been authenticated and this ticket says is this user and this user has this level of privileges. Remember, you create user accounts on your device, so you can have guests, can have admin and the rest of them. Based on the password or the credentials that has been authenticated, it will now activate that particular privilege that's attached to that particular user. The client will now use that ticket that's been given to it, right, which is what it's supposed to use to verify its identity. It will send the ticket to the granting server. The granting server now generates and sends a ticket to the client. The client presents the ticket to the server, then the server grants access to the client. So typically, it's a service that allows for authentication and all. And I've always maintained any place that there is a database that must be checked against before authentication is given, then there can possibly be any trouble. Anything can happen, especially if it's in a network environment. Because the fact that there is a server or a database somewhere suggests that it is a service that is being offered or issued, right? Someone's asking a question. No problem, sir. No problem, Bello, Abba Ibrahim. No problem. I actually also, class started late today. It's actually already past 10. We've not even touched wireless. And we're still dealing with the network aspect. Class started late, so it was a network issue. Hopefully, we would overcome it in this part of the world. I pray that all of you get Starlink and use, so that if you know you get this kind of problem, instead of using mobile network internet. Right. So as long as there's a server, right, suggests that there will be a network or access to it to be able to grant any form of service. In this case, we're looking at it with respect to a database. So since this is what happens, typically we're looking at going to meet a server. Server grants you a ticket. Ticket is used to now check with the server. Server grants you an access, and then of course you are giving, access to get. If that is the case, then it's very likely that it can be attacked, right? So Active Directory uses lightweight directory access protocol as an access protocol. So typically it's lightweight, right? And Windows LDAP implementation supports Kerberos authentication. So LDAP uses an inverted tree hierarchical structure called the directory information tree, and every entry has a defined position. So the distinguished name represents the full path of the entry, one of the most common attacks in Kerberos golden ticket attack, right? What that means, if you have a golden ticket, it means that you are good to go. You bypass every other authentication process, because once you show the ticket, you are good to go. An attacker can manipulate Kerberos tickets based on available hashes by compromising a vulnerable system and obtaining the local user credentials and password hashes. If the system is connected to a domain, then the attacker can identify the ticket granting ticket, right? That's the KRB, that's Kerberos ticket granting ticket password hash to get a golden ticket. Once he gets that, it's good to go. So Empire is a post-exploitation framework that includes a pure PowerShell Windows agent and a Python agent that can be used to perform golden ticket and many other types of attack. Somebody mentioned yesterday when we were having class that the journey to ethical hacking is a long one, and I agree. I foresee a situation where Cisco might further break this course into perhaps, let's say, intro to ethical hacking and then ethical hacking itself. Maybe intro to ethical hacking, then essentials of ethical hacking for have ethical hacking. I would actually even champion within our own community, champion such suggestions because it would help. That way, it throws people into learning curve that exposes them to what should be expected. Because typically, once people hear ethical hacking, they want to jump into it and collect tools and use, which is cool. And I don't have any problem with that. But there's where it gets to. You cannot really go beyond using tools. There's one way to know that this is the tool and this is what I'm using the tool for. Some people just use the tool. It's just like saying there are people who drive cars. But if the car has any problem, they will park it there. There's a particular gender. I'm sure the gender is aware that once the thing happens, they'll just pick the phone and call the other gender. So do the math. And that's like ethical hacking and knowing how to use the tool. So the tool is like the car, and then using it is like driving it. But if there's a challenge, knowing where to touch or what to do is another skill, which of course has been developed over time by using not just driving the car, but knowing how to use the car. So that's what we're doing right now. And it can be, in a large sense, boring and tiring. So please bear with it. And hopefully, as we learn, it's going to become clearer. So similar attack is Kerberos silver ticket attack. And these tickets are forged tickets for a given service or a particular server. So the difference between the silver ticket and golden ticket is simply the fact that let me try to clear the air, okay, so that we don't have how do I put it now? In cybersecurity, actually, golden ticket or silver ticket are tickets that are forged. The difference between the silver ticket and the golden ticket is that silver ticket is largely for specific services, right? Or particular server, particular services hosted on particular servers, right? And it is it's on Windows. So for somebody's asking a question, yes, yes. So I think what we may need to do is perhaps even pause class here and continue from this part by tomorrow. Because I was hoping to deal with the module today and then finish the module, but because we've actually crossed the time, and I know that attention span will become very slim. So let's conclude class. So this is the slide we're on. We're looking at silver attack. So we'll start from here tomorrow and conclude this particular module because I really want to deal with this module. I talked about it before. It's very, very important that we understand the network aspect of every attack so that it helps. So, because I observe a lot of people are beginning to go off, and I wouldn't want you losing it. I also don't want to lose my trail of thoughts, thinking that a great number of people are not part of the class as it is right now. So I would have to conclude class. We'll continue tomorrow. Time is way past. Some people have things to do tomorrow, one of which I am. So we're going to be continuing from here. This is, I don't know what slide number this is, slide number 40. So we'll start from here we'll continue from here tomorrow. The recording for this would be available. Like I explained, the recording for the other ones are available. I'm trying to just merge all of them. So let's continue tomorrow, same time from 8. Hopefully, I'll try to log in from around 6 so that I stay online, so I don't get to face the issue that I faced today. Thank you all for being available today, and thank you for your time. I hope it was informative. I'd like to thank you for listening, and then we'll see you tomorrow. Thank you all very much.